Hi, Year 6. Welcome to your maths lesson. So let me just get started by sharing the screen with you. So today is the 5th of March 2021, and today we are learning to solve problems involving volume and capacity. So yesterday we looked a little bit at, we looked at increments and how to read scales. Today, I will be testing your knowledge on how you can apply that to this starter, focusing on volume and capacity. Okay, so answer these 5 questions here, and then can you figure out what goes in all of these blank spaces? So pause the screen and have a go, and then we'll go through the answers together. Okay, so here are the answers. Feel free to mark this and skip ahead to the next part of the video. But if you'd like me to go through some of them, then I will do that with you now. So for the first one, it's 34 millilitres, because if we count from the bottom, we've got 10, 20, 30. It doesn't go, the amount of liquid in this doesn't go past 40, so we don't count to 40. Instead, let's stay at 30 and work out what one increment is. So we can see that if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 increments, and 10 divided by 10 gives us 1. So each increment will be 1 milliliter. So let's count up in ones. We got 1, 2, 3, 4. So 34 milliliters for that one. We then have 95 for this second question, because each increment was 5 milliliters. So you can work that out by doing 20 divided by, there are 1, 2, 3, 4 increments. So 20 divided by 4 will give you 5. And if you count up in fives from 80, we've got 85, 90 and 95 milliliters. For this one was pretty simple. You can see that the line is halfway through 30 and 40, and you would have found that each increment is 2.5 milliliters, and hopefully you got 35 for that one. We've got 15 milliliters for this one, because each increment, if we divide 20 by the number of increments underneath, we've got 1, 2, 3, 4. 20 divided by 4 gives us 5. And if we count up in fives, we've got 5, 10, 15. So you've got 15 milliliters for that. And you should have applied the same method to the last one there. Hopefully you remembered there are 1,000 milliliters in a litre, and if we go from a smaller unit to a larger unit, so milliliters to litres, we have to divide, and if we go from a larger unit to a smaller unit, we multiply. It's always the opposite of what you think, and you are multiplying and dividing by the number of units there are in the other unit. So let's have a look at the big question. Can you pause the screen here and have a go at answering this question if you want a challenge to test your memory on what we did before ratios? So I made 2 litres of fruit punch for a party. The maximum capacity of the jug is 4,200 millilitres. How much more punch could I have made so that the jug would be full? Write your answer in millilitres. So pause the screen, have a go. But for now, I want to go through some vocabulary that you might see in this question and the other questions we'll be going through. Let's have a look at this. So our learning objective says we've got to solve problems involving volume and capacity. So I want to go through the difference between volume and capacity. Capacity refers to the maximum amount something can contain, and volume is the amount of 3D space an object takes up. So if I get my dotted line, the capacity, so here's my container, the capacity, the maximum capacity of my container is here. And if I was to put some liquid in my container and it comes up to here, then this would be the volume measured. Okay, the volume would be how much liquid or how much 3D space an object takes up, and the capacity is the maximum amount that the container, so the object, the something, can contain. Okay, I also wanted to look at some Language used in worded problems. So for example, in total, altogether. Remember, in total, altogether refers to addition. How much more or how much is left, that will refer to finding the difference. And when you find the difference, you need to do subtraction. And a lot of the questions that I've got written for you will say, write your answer in milliliters or write your answer in liters. And this will require you to use multiplication or division because you will be converting, okay? Just like we looked at here. I want you to take that in, remember these, and if you feel like you need to refer back to this, then feel free to do so when you're answering questions. But this is just a useful reminder for keywords in questions when you are answering them. So let's have a go at answering the big question together. So I want to highlight my keywords first. So I made 2 litres of punch for a party. The maximum capacity of the jug is 4,200 millilitres. How much more punch could I have made so that the jug would be full? So how much more? And they are asking me to write my answer in millilitres. Okay, so first, before we do anything, I want to convert all of my values into what my answer needs to be, and just because it will make things a lot easier if I start off this way. So they want me to write my answer in milliliters. Well, the maximum capacity is already in milliliters, and if I convert 2 liters to milliliters, if we look at our conversions to help us, liters to milliliters, we multiply by 1,000. So 2 times 1,000, easy peasy, gives you 2,000, and it should be milliliters. Okay, so the maximum capacity, now I want to label my bar model. So the maximum capacity is 4,200 milliliters. Okay, and I've made 2 liters. So I'm going to draw my line. This is roughly about 2 liters. And remember, we said that that is 2,000 milliliters. Okay. It's asking me how much more punch would I have made so that the jug would be full. So I need to find out how much more. So all of this that I need to make in order for my jug to be completely full and reach the full 4,200. So if I remember, going back to here, it says how much more? Oh, that means we have to do subtraction. So if we do that now, 4,200 minus 2,000, these are all in milliliters. 0 take away 0, 0 take away 0, 2 take away 2, sorry, 2 take away 0 is 2, 4 take away 2 is 2. So hopefully, if you did have a go at this, you should have got 2,200 milliliters for how much more was left in the jug. All right, so I just wanted to have a look at this, okay, because sometimes we think that volume is only referring to things like water or milk or juice, but actually it refers to any 3D space taken up by something. So for example, toothpaste in a tube, or shampoo in a bottle, or even shoe polish in a tin. It's the 3D space taken up by an object, and that's the volume. And here we have a ketchup sachet, you might have seen one of those before, and a milk carton. So these are all different types of things that can show volume and capacity. It's not always just a liquid, okay, in terms of like water and juice or whatever, okay? Right, I'm going to have a go at this question here. What I'd like you to do is really think about what my process is. What am I doing as I'm answering this question? So first, I'm going to highlight my keywords. It says, if there are 50 milliliters of water in a container, in container A, and 0.4 liters of water in container B, how much water is there in total? So it's asking me how much water is there in total. Right, Oh, and they're asking in milliliters. Good, I would have missed that if I didn't highlight that. So let me get my pen. I've got my bar model ready for me. You will draw this as soon as you've finished highlighting. So I need to find out what my whole is. Now, it says there are 50 milliliters in container A and 0.4 litres of water in container B, and they're asking me to find the total. So I don't know what my whole is. I'm going to put a question mark there. Now, because it's asking millilitres, and not all of my values are in millilitres, I'm going to convert. So I've got 0.4 litres, and I want to convert that to millilitres. And if we look back at the conversions to help us, litres to millilitres multiplied by 1,000. And if we do 0.4 multiplied by 1,000, you should have got 400 millilitres. So now I know that one part, so this is container A, is 50 millilitres, and the other part is 400 millilitres. So that means I can add these two together because it's asking me total. Remember, total means addition. I can add these two together to get my whole, and that would be 400 plus 50, and you should have got 450 millilitres. Always remember your units, okay, when answering questions. Right, let's do this one together. So we're going to highlight this together, and then I want you to have a go. So I'm going to get my highlighter ready. Let's read it together. I fill a 1,500 milliliter flask with soup. I have 0.55 litres for lunch. How much do I have left? Write your answer in litres. Okay, let's highlight through this. I fill a 1,500 milliliter flask with soup. I have 0.55 for lunch, so that's taken away from this, isn't it? How much do I have left? Write your answer in litres. So remember, how much do I have left? We're using subtraction here, and write your answer. You're going to have to do conversions, okay? So pause the screen, have a go, and then we'll go through this answer together. Okay, how did it go? Let me get my pen ready. So we've got 1,500 milliliter flask. And hopefully you would have found that that is our whole. 1,500 milliliters is the whole. It wants our answer in liters. So what I should have done is actually convert before I label my bar model, because that would just make things a lot easier. So if we convert 1,500 milliliters to liters, remember converting from milliliters to liters, we divide by 1,000. So let's do that. 1,500 divided by 1,000 should have got you 1.5 litres. So then I can label my bar model with 1.5 litres as the whole. How much do, and I've had 0.55 litres for lunch. So let me draw a part that's 0.55 litres for lunch. How much do I have left? So we want to work out this part here. We don't need to worry now about write your answer in litres because everything's in litres for us already. So because we are finding how much is left, we have to do a subtraction, and we do our whole, take away the small part. So we've got 1.5 take away 0.55, and I'll put a placeholder here. So 0 take away 5, we can't do that. So I'm going to regroup here. So there we go. Okay, so 10 take away 5 gives us 5. 14 take away 5 gives us 9. And 0 take away 0 is 0. So you should have got 0.95 litres as your answer for this question. Well done if you got that. Feel free to go back and listen through these two examples together. Again. Let's go through a success criteria before I get you to do a question on your own. So the success criteria to be able to be successful in solving problems involving volume and capacity, you will need to do the following. Write down keywords so you would usually highlight, but you can't do this online. So I'd like you to write down the keywords, convert your values to the unit the question is asking you to give your answer is. So always convert first. It will make things a lot easier for you. Then draw your bar model and label it appropriately. So what's your whole, what's the parts, etc. And what are you finding out? And then I'd like you to select the correct operation to work out your answer. And remember, you have some support here to help you when you're working your questions out. We've got in total altogether, how much more or how much is left, and write your answer in. Remember to use that. And going from milliliters to liters, we said it's divide by 1,000. And going from liters to milliliters is multiply by 1,000. Okay, don't forget that. So I'm going to give you a question to do now. Pause the screen here and have a go. We'll read it together first. There are 8 liters of water in a bucket. 1,550 milliliters evaporates. How much water is left in the bucket? Give your answer in milliliters. So pause the screen here and have a go at answering that question. Great, how did it go? So if we, oh, it changed color. So if we highlight the question, you should have highlighted 8 liters. Oh, you should have highlighted 8 liters of water in the bucket. 1,550 evaporates. How much water is left in the bucket? And give your answer in milliliters. So hopefully these were the keywords that you chose to highlight or write down. I'm going to reveal what your first step should have been. You should have first converted your 8 liters to milliliters, as it's asking you to give your answer in milliliters, and it will make your life a little bit easier. Then you should have drawn your bar model and labeled it appropriately. So your whole would have been 8,000 milliliters, and then your part would have been 1,500. It's asking you how much water is left. So you're working out this section here, and because it's asking how much is left, you should have done 8,000 take away 1,550. When you do that, you should have got 0 take away 0. Oh, that's a highlighter. Is 0. 0 take away 5 you can't do. Here is 0 take away 5, you can't do that. So if we regroup with 8, you've got 7 there, 10, 9, 10 again. So 10 take away 5 gives you 5, 9 take away 5 gives you 4, and 7 take away 1 gives you 6. So you should have got 6,450. What am I forgetting? Milliliters. Good, well done. Right, so can you now head on over to Teams and complete the assignment for today's lesson? Remember, refer back to the success criteria and the conversion facts for milliliters and liters, as well as your prompts for what operations to use. So use this page here. The success criteria will be at the top of your quiz, so don't worry too much, but feel free to come back to the video here. That is the end of your lesson, and I will see you next week. I'm so excited. I cannot wait to see you all. Have a lovely weekend and enjoy your assignment. Goodbye.